Hey guys, today we're going to work with classifying types of chemical reactions. So scientists and chemists classify chemical reactions to organize the many reactions that occur daily. There are 5 main classifications that we're going to use in this class. The first classification is synthesis, and another word for synthesis is combination. This is where 2 or more reactants combine to produce a single product. So notice this generic formula. On the left-hand side of the arrow, we have 2 individual elements, and on the right-hand side, we have 1 compound. That is, again, a generic formula. You could have 3 elements, you could have 4 elements, and have 1 outcome from the chemical reaction, but in essence, it's 2 individual things combining to create 1. So examples of this are like pizza. You have the pizza dough, the sauce, the cheese, and then any toppings you want to add. That can be as little as 3 items combining into 1, as many as 7. Another example would be like peanut butter and jelly sandwich. If you have bread, peanut butter, and jelly, you add them to create the sandwich. Underneath, this is one example, which is the combination of iron and sulfur to form iron sulfide. So notice we have iron by itself, we have 8 sulfurs bonded together, and the outcome is iron sulfide in a compound. Now this is already balanced for you, so you don't have to think about doing that, but it's just the idea that we have a plus sign on this side and nothing on this side. It is just a single compound. The next one is decomposition. A decomposition reaction is where a single compound breaks down into 2 or more products. These types of chemical reactions require energy. So the generic formula is the exact opposite of the last slide. We have A and B combined into a compound, an arrow, and then A plus B. Now I could also add energy to this. So it's A plus B plus energy, arrow, A and B separate. So the whole idea is that you have to apply energy to separate these elements because they're happy. They're content, they're bonded, they're sharing their electrons, and they are already a stable compound. We have to add this energy in order to break apart those bonds because they're happy and don't want to change. So one example is electrolysis of water. Essentially, when you run electricity through water, you can separate out the H2O molecules and have H's and O's on their own. Now, they are going to be bonded to another H or another O, but it's no longer a water molecule. It is now a hydrogen molecule and an oxygen molecule. Again, this is just one example. Real life examples that I like to use is if you do order pizza and one of your friends likes mushrooms or anchovies and you're not a fan, you would have that piece of pizza, and on a separate plate, maybe you would have the anchovies or the mushrooms that you picked off. Another example is coming in outside from the cold. If you're outside and playing in the snow, and you come inside with your hats, your gloves, and your scarf on in addition to your snowsuit, eventually you're going to take those layers off. And you were starting kind of like that little kid from the Christmas story, and you're going to end in just your jeans and your t-shirt with your wet clothing drying by the side door. So decomposition is things falling apart. Single replacement is what I like to call Mr. Steal Your Girl. This is when one element trades places with another element inside of a compound. So the generic formula, in the top we have A by itself and B and C bonded in a compound. After the reaction takes place, C has switched partners. C is now bonded with A and B is by itself. So this example, or this generic formula, you always want to look for an element who's alone. And after the reaction takes place, find a different element who's alone. So down here we have one example, which is copper and silver replacing each other. On the left, copper is by itself, and silver is bonded with nitrate. On the right, now silver is by itself, and copper is bonded with nitrate. So these 2 elements just flip-flopped locations, and one of them is in a compound now, and one of them is alone. So the real-life example that I like to use for this is somebody who plays 2 sports. If you play football in the fall, you have your football jersey that you wear every Friday night. But your basketball jersey is hanging in your closet until basketball season starts. So that's you here. Basketball jersey hanging in the closet, you wearing your football jersey. Then the seasons change and the reaction occurs. Now you're in your basketball jersey and your football jersey is in the closet in storage. So you're just swapping out one thing to form this chemical reaction. The next one, though, is double replacement. And in a double replacement reaction, the metals and the nonmetals are already in two full compounds, and they completely switch partners. So in this example, we have A and C bonded together in this first spot, and B and D bonded together. Well, in double replacement, the two nonmetals trade partners, and after the arrow, we now have two completely new compounds. So an example of this, if you and your friend are sitting in class next to each other, and your friend realizes, oh man, next period's gym class, but I wore my flip-flops today. Your friend might ask you if they could borrow your shoes for the class period, and you wear his flip-flops to your next class, and he wears your shoes to gym. That's a double replacement reaction. Both compounds, you and your friend, switch one item of clothing. Another example is the TV show Wife Swap. In those shows, the dad and the family stay in their house in their city, living their normal life, and their mom trades places with another mom for a week or two. And the whole idea is that you're completely making a brand new compound or a brand new couple and seeing how this experiment's going to go. So double replacement, two items completely switch partners and create two brand new compounds. The hint for this one is you have two full compounds on either side. So for this example, Na is with hydroxide and copper is with chlorine. After the chemical reaction occurs, Na or sodium is now with chlorine and copper is with hydroxide. So these two endings just flip-flopped locations. So again, here are the basic examples in picture form. You have synthesis, which is this first one, A plus B, and then A and B bonded together. So you would use synthesis to describe this. A and B together to A plus B on their own. This would be decomposition. A and B bonded together, C by himself, and now A and C bonded together and B by himself. This would be considered single replacement. A, B, C, D, and trading partners. This would be considered double replacement. But there's one more example that's not so easy to see. That example is combustion. A combustion reaction is when oxygen combines with a substance and releases energy in the form of heat and light. So the big key here is that you have to see O2 before the arrow by itself. It can have a coefficient, but it may not have another element paired with it. And this is always the first type of reaction you should be looking for. If you see an O2, you immediately have to write down combustion on the line. It could be a combustion and a single replacement, but combustion is what you are going to be graded on. So looking at this chemical formula, this O2 is our indicator that it's a combustion reaction. If I have CO plus CH4, this is not combustion because that is an oxygen, but it is not an oxygen molecule. If I have CO2 plus CH4, this is also not considered combustion because I do not have oxygen or O2 by itself. Now, as we write this, we could also add in plus energy at the end, because the whole purpose of these is that there is an energy output when oxygen mixes with whatever this substance is. So this is the fifth type of chemical reaction. So far we have synthesis, which is combination, two or more things adding into one. Decomposition, which is falling apart, one big thing getting smaller. Single replacement, who's Mr. Steal Your Girl, you have one element trading places with another. You have double replacement, which is two complete compounds changing partners. And you have combustion, O2 before the arrow. The whole idea from here on out is that you are going to not only be balancing your chemical formulas, but you will also be adding the type of chemical reaction they are to that information. So I'll see you in class so we can go ahead and practice this.